In this module, you're going to learn about Java classes and write your very first Java program.
In this module, you're finally going to start learning the Java language. In fact, you're going to write your first Java program. But before we do that, we have to have a better understanding of what a class is. So we're going to identify the 4 components of a class and how to use them. We're also going to take a look at the main method and how it acts as an entry point into our Java application. And then finally, we'll go through the compiling and the execution steps for a Java technology program. Before we go ahead and look at a class and the 4 major components that go into a class, let's refresh ourselves on what the difference is between a class and an object. Remember from Module 2, we talked about the blueprint to house correlation. That to build a house, you first have to start with a blueprint. Then once you have that blueprint, you can create as many houses in that style as you want. Same thing goes for classes and objects. Before you can get any objects created, you first have to have its blueprint, which is the class. So once you have the class structure created, you can use that to create as many objects of that class as you like. We call those objects instances of the class. So for instance, a shirt object is an instance of the shirt class. Let's go ahead now and take a look at our first class. Let's look at the shirt class. Remember, the class is the blueprint that tells the computer how to make objects. So this class blueprint tells the computer how to make shirt objects. There are 4 major components that can go into a class. There's other things as well, but these are the 4 that you'll find most often. So as I discuss each one, go ahead and roll over the link on the right to see the code associated with that component. Now we're not going to go into much detail here about each of these components. We'll be doing that later in this module and in subsequent modules. We just want to get a high-level overview of the class structure and what can go in it. So let's start with the class declaration. If you roll over that link, you'll see that lines 1 and 18 have been highlighted. This is the class declaration, and it is required. And this is all that you need to make a valid class. Now if all you had was this, you'd have a very uninteresting class and very uninteresting objects. You either need some attributes or some methods to jazz the object up. So let's go ahead now and look at the attribute variables. Now the variables are your properties, your characteristics of your object. They're also your data holder. They hold the data for the object. So in this instance, we see that the shirt class has shirt ID, description, color code, price, and quantity in stock for its attributes. So every shirt object that gets created from this class will have its own set of these attributes to hold its own set of data. Now let's go ahead and take a look at the methods. We only have one method defined in this shirt class called display shirt information. Now remember from our previous discussions that methods are our operations. They tell the class what to do. It's what the class can do. So in this instance, if we were to execute the display shirt information method, it would print out all of its information to the command prompt window. It would print its shirt ID, its shirt description, its color code, its price, and how many of them are in stock. Lastly, we can put comments in. Now comments aren't executable code and they don't change the behavior of your program, but they're for us, the programmers, to better understand what's going on in our code. Let's go ahead and talk a little bit more in depth about the class declaration and where it goes. First off, the class declaration goes in a text file. Now each class declaration should be in its own file. Now you can put more than one class declaration in a text file, but this gets a little bit more advanced, and so for us, we're not going to be doing that. We'll always have each class declaration in its own text file. Now the name of the text file has a naming convention. You must follow it. Okay? So if the class is called shirt, the class declaration must be in a file called shirt.java. And also it is case sensitive. So if our class is called shirt with a capital S, our file name must be called shirt.java with a capital S as well. If you do not follow this, you will run into problems when you compile and try to execute the program. So make sure that the class name and the file name match up. Okay, now that we got that out of the way, let's go ahead and look at the class declaration syntax. As you can see, we have a syntax box to our left and we have the code to the right. So go ahead and roll over the modifiers in the syntax box, you'll see that every class declaration has an optional set of modifiers that can go before it, such as public, abstract, or final. We're going to be talking about these modifiers later on. The next thing we have to have, and this is a must, is the class keyword. This is required. Okay, every class declaration must start with this, unless it has some optional modifiers before it. And remember, Java's case sensitive, so this has to be class all lowercase. After that, we have the class identifier. This is the name that you give the class. For example, shirt. Now, typically, we use nouns for class names. Okay, and we also always capitalize the first letter of each word. So, for example, shirt has a capital S. Customer would have a capital C. If you have two words in it, like my class, you'd have a capital M and a capital C for the word class in the middle. You should always try to use whole words and not abbreviations or acronyms if you can, because otherwise that can get kind of confusing, unless it's a well-known abbreviation or acronym, like everyone knows what FBI means. Also, you should not use spaces, or you cannot use, I should say, spaces, periods, dashes, or begin your class name with a digit. Also, again, very important, Java's case sensitive. So whatever you name it, you have to make sure that whenever you refer to that class in any other part of your code, you always use the same case when you're referring to that class name. And the last thing that you absolutely have to remember to include in your class declaration are your left and right curly brackets. The left curly bracket begins the class body, and the right curly bracket ends it. The class body is where the attributes, methods, and or comments go. Now it's time for a self-check to see what you've learned. After you've answered each question, click Check Answer to see if you're right, or to see what the correct answer is. The next class component we want to talk about are attribute declarations and their initializers. Now, we aren't going to go into all of the details here because in the next module we'll be talking more about these in depth. But we do want to understand the general syntax of how to declare an attribute and how to initialize its value. Now remember, attributes are our data holders. They hold the data for our program. They're our variables. So let's go ahead and start off with the modifiers. Roll over the modifiers word and you'll see the modifiers highlighted down in the code example. All of our attributes have the same modifier, public. Now, modifiers are special keywords that modify the way the attribute functions. Some examples are public and private. Now, we'll be going more into modifiers later on in the course. Now, modifiers are optional, but the type is not. You must always specify the type of the variable. The type is the type of data that the variable is going to hold. For instance, it might be int, meaning that the variable will hold only integers. It might be the word string, meaning that the variable will hold text data. It might be the keyword double, indicating that the variable will only hold floating point values, so numbers with a decimal place. We'll be talking more about the different data types again in the next module. Let's take a look at the identifier. The identifier is the name that you give the variable. You can use any name you want. You just have to make sure that you start with a letter, and there's a couple other special characters that you can use, but we're not going to do that in this class. We're going to stick with letters. And typically, we use lowercase letters. So go ahead, give it the name that you want. Make sure it's a descriptive name, though. After that, you can give it an optional value using the equal sign, and this will initialize the variable to that value. We'll talk more about initialization again in a later module. And lastly, make sure you end the variable declaration with a semicolon. Semicolons in Java indicate the end of a statement. You can kind of think of a statement as one line of Java code. Comments are another class component. Now, they don't really do anything, they don't execute, and they don't change the behavior of the program in any way, but they are still very useful. Now, there's two major types of comments that we put into our code. There's a third one called a Java dot comment, but we aren't going to be discussing that one here. So let's go ahead and first take a look at the single line comments. So go ahead, roll your mouse over the single line word in the syntax box, and you'll see the associated single line comments in the code. As you can see, we have several of them. Now, single line comments start with the / and continue to the end of the line. So that's why they're single line. Now you can either have, as we see in the code, partial line comments or full line single comments. Just remember, the comment begins at the / and continues to the end of the line. We also have what are called traditional comments. Now, traditional comments are used when you want your comment to span multiple lines or large blocks of text. You begin with a /* to start the comment, and then you end it with an */. So you actually have to specify the end of the comment, unlike the single line comment, which automatically terminates at the end of the line. The final class component we'd like to talk about are the methods. Now remember, the methods are the operations of the object. It's what the object can do. It's its functionality. Now you can have 0 methods, 1 method, 100 methods in your class. It's up to you. Now we're just going to talk about the general syntax for setting up a method, and then in a subsequent chapter we're going to get into more detail about all the things you can do with methods. So let's go ahead and get started. Roll over the modifiers link in the syntax box, and you'll see what modifiers we have for this method. We only have one method in this class, and it's called display shirt information. As you can see, this method has a modifier of public. Now remember, modifiers are just like attribute modifiers, and that is that they're special keywords that modify the way the method behaves. Some examples are public, private, and static. Now modifiers are optional, but the next thing is not, and that's the return type. You always have to specify what the value is that the method returns. Now every method can return at most one value. Now if it doesn't return a value, it has to specify the keyword void. So in our case, our method is not returning a value, so it's using the keyword void. If it did return a value, we would see something else. We'd see something like int, saying that it returns an integer, double, saying that it returns a floating point number, string, saying that it returns text, or it could even return an object, such as a customer object. After you specify the return type, you then have to give your method a name. So we have to give it its identifier. So in our case, our method is called display shirt information. Now you're going to want to use descriptive names, okay? So don't be afraid to use like multi-part names or multi-word names, so like display shirt information. You want to have it be descriptive. Also, we're going to start our method names with a letter in this course. There's a couple other characters you can use, but we're going to stick to letters, okay? After the initial character, you can then go ahead and use numbers, but you have to start it off with a letter. Then, after you've given the method a name, you have your parentheses, and inside parentheses you have your arguments. Now arguments are optional. It's data that's being input to the method. Now in our case, we have no input into this display shirt information, so our parentheses are blank. You always need the parentheses though, whether you're specifying any arguments or not. Then you have to have your left and right matching curly braces, just like we had to have them with the class declaration. This begins and ends the method body. And then inside those curly braces, you're going to have your method code. That is the statements, the Java statements that you want the method to execute. And so as you can see, if you roll over the method code block link, we have 5 statements that this method would execute if it were run. And what it would do is it would print out all the shirts information out to the console window or to the command prompt. Now it's time for a self-check to see what you've learned. After you've answered each question, click Check Answer to see if you're right, or to see what the correct answer is. Okay, now that we've gone ahead and created the shirt class, can we go ahead and run it? Is it a program? Well, no, not yet. We're still missing something. You see, we need something that will create our shirt object and then either set an attribute or execute one of its methods, put it through its paces. And to do that, every Java program needs a main method. Now, a main method is an entry point into your program. It's the starting point of your program. Now, that main method can be placed in any class that you like, but typically we would put it in a class all onto its own class, just for the entry or the starting point of our program. So we're going to create a second class called ShirtTest that will have the main method in it, and it will be our starting point for our program, and it will go ahead and create our shirt object, and then it's going to go ahead and display the shirt information by calling the display shirt information method on the object. So let's go ahead and take a look at this class and the main method. So you see we have a class here called ShirtTest. So you should be familiar now with the class declaration in the edit window. It also has one method, and that method is called main. Now the main method, the entry point method to our program, must follow a set standard. Okay? So the first thing you have to have is you have to have two modifiers on your main method. It must be public static. So you see in the syntax window, if you roll over the keywords public static, you also see them highlighted in the code window. So those modifiers are required. We also have a return type of void. Your main method is to return nothing. Then the method identifier is main. It must be called main. That's how the Java environment is going to know that this is the entry point to your program. And then lastly, this method must accept an array of strings as its argument. Now, we haven't talked about arrays yet, so don't worry about it. Just follow that syntax. So it's string, space, and then the args, and then the brackets. And then you can see the code block that we have in our main method. So if we take a quick look at what's happening here, we're declaring a myShirts variable of type shirt. So remember our variable declarations that we talked about, okay? So this is declaring a myShirt variable. It can hold one shirt object. The next line of code on line 5 in the edit window is the actual code that's creating our shirt object. It's using an operator called a new to do that. Now we haven't talked about object creation yet, so don't worry about it. We just want to set up this test program to see what's happening. And we'll get into object creation in much more detail later on. And then line 6 is actually calling the display shirt information on that shirt object, and it will then print out the shirt information onto the console window. So there's a lot going on in this very simple program. So just to reiterate, to be able to run our shirt class, we have to have a second class called ShirtTest with an entry point to our program, and that is the main method. This will start up the program. Now when the main method executes, it will go ahead and create a shirt object and then call the display shirt information on that shirt object. And then our main method will exit, and so will our program. So it's time to go ahead and run our program, right? Well, not just yet. We still have to compile the shirt.java file and the shirttest.java file. You see, it's just source code right now. It needs to be translated into what we call bytecode. All right? So we're going to make sure that we've placed those two files in the same directory, and then we're going to go out to the command prompt in that directory, and we're going to run a program called the Java compiler. And we're going to compile the shirt class and the ShirtTest class in that order. Now, in this example, we're just going to run through the ShirtTest compiling phase for you, just to get you a feel of what happens. So, in the command prompt, we're going to run the javac command, and we're going to give it as input the name of the class file that we want to compile. So, in this case, ShirtTest. Now, again, you're going to want to first compile the shirt.java file and then this one, but we're just doing one here as an example. So on the command prompt, type javac shirttest.java. Now what that will do is that will go ahead and start the compiler. Now the compiler is going to take the shirttest.java file, bring it into the compiler, and start to go through the code, and it's going to get out as output a file called shirttest.class. Now that .class file is the bytecode file. Now remember in an earlier module we talked about how Java does not compile to binary code for a specific platform, but instead goes to this intermediate bytecode file that can then be interpreted by the Java virtual machine on a number of platforms such as Solaris, Linux, Windows. So we get as output this bytecode file. Now if the compiling step doesn't work, we would see some errors, some compiler errors come out. If the compiling does work, we won't see anything printed out on the command window. And this is something that throws a lot of students off. They think there should be something that says success or something, but it isn't going to do that. If you don't get any output when you run the javac compiler, that means it was successful. If you get a bunch of error messages out, that means you've got compiler errors and you have to fix them and then re-go and compile it again. Alright, I mentioned to you that when you compile your program and you don't see anything as output in the command prompt window, that meant the compiling step worked. But if you do see some output, then you got some error messages and you have some things to fix. Now, one of the things that throws a lot of students out is how to read those error messages. So we want to try to help you out to decipher what the error message is telling you. Now, there's 4 things that the error message is going to tell you. It's going to tell you the file name of the file where the error occurred, the line number of the error in that file, the error that it found, and the possible column location of the error. So on your right hand side you've got some links. Roll over those links and we'll see in our 2 examples where that information is displayed in the error message. So let's go ahead and roll over file name. You see we have 2 examples of errors here, and they both occurred in the shirt.java file. Roll over the line number. Now you can see that they occurred at different line numbers. The first error occurred in line 1, and the second error occurred in line 13. Go ahead and roll over the error. Let's see what errors we have. The first error we got was class or interface expected. Now this happens sometimes if you mistype the word class. Remember class is case sensitive, so it has to be all lowercase. So if I mistyped it, like for instance, you see in my example, I use an uppercase C for class. That's a no-no, so I got that error message that I was expecting the keyword class or the keyword interface, which we haven't talked about yet. Then in the bottom one, you see it says semicolon expected. So you have to end all of your lines with a semicolon. So what it's telling me is that my line is missing a semicolon. Now this is one of the things that throws people off. See, sometimes the compiler can't totally determine which line it missed the semicolon. So it's showing me a line with a semicolon. If you go into the source code file and you look, it's actually the line above it that was missing the semicolon. So it displayed the line below it, but it's actually the line above it that was missing the semicolon. So don't get thrown off by that. I have a lot of students where they think hey, there's a semicolon on this line. What's wrong? Look around that line of code it's showing you to see if the error is either on the line above, the line below, something like that. Then lastly, it will also try to show you the possible column location of the error. Now again, that can sometimes be misleading. Usually that column indicator ends up being a little bit further down the way than where the error occurred. So the error occurred and then it detected that there should have been something that wasn't there, and so it puts that column locator a little bit off. Sometimes it's right on, sometimes it's just a little bit off. So don't get confused. Look around that column locator and you should find it. Tracking down compiler errors when you're new to Java can be a pain. So we're going to give you 2 types of tips here. The first is one way to help you with the compiler error messages so you're not overwhelmed in the beginning. And the second is some tips to minimize the error messages that you see when you compile. So the first thing we're going to talk about is file dependencies. You always want to compile your Java files compiling the least dependent class first. Now, what does that mean? Well, basically it means if a file uses something from another file, then that file is dependent on the other file. So you should always compile the other file first. So for example, we have two files in our example. We have shirt.java and shirt.test. Now, shirt.test creates a shirt object, so it uses the shirt.java file. But the shirt.java file uses nothing from the shirt.test.java file. So you see the shirt.test file is dependent upon shirt, but shirt.java is not dependent upon shirt.test. So we're going to compile the least dependent one first. So that's the shirt.java one, the one that doesn't rely upon anything from the other one. And once we've compiled that one, and we have it all compiled correctly, we will then go ahead and compile the shirt.test.java file second. Now, you're asking yourself right now, well, why does it make a difference? Well, it's because when you compile a file, it will also go and check to see if all the files that it's dependent upon have already been compiled as well. And if they haven't been compiled, it will go ahead and compile them. So if we compile shirt.test first, and we have not compiled the shirt.java file, then guess what? It will go out and compile shirt.java as well. Now, if it finds errors in the shirt.java file and the shirt.test.java file, we will get error messages from both files. Now, this completely throws students off. They've got error messages now coming from two different files. They don't look at the file name to see where the error message came from. They just assume it was coming from the file that they compiled. And so they're looking in that file and they can't find the error. It's because it was coming from another file that got compiled in the compilation process. But if we've already compiled the other file first, so if we've already compiled the shirt.java file first, then shirt.test has no need to go out and compile it. And so if there is an error, it will be coming from the shirt.test.java file. So that's number one. Always compile your file dependencies with the least dependent file first. The second tip is just some good coding practices that will minimize a lot of your compiler errors that you're going to see. So go ahead and roll over the tip that we have on the right hand side, and you'll see the code that we're talking about. So tip number one, make sure you have matched up all your left and right braces. Now, this is always forgotten. Students forget to match them up, and you'll get lots and lots of error messages if you don't have them. If you have two left curly braces in your source code file and you have only one right curly brace, somewhere you haven't matched them up. They always have to be equal. Tip number two, make sure each statement ends with a semicolon. Don't forget the semicolons. That's another big one. If you leave that off, you're going to get that error message that we talked about earlier. Lastly, make sure you have used the correct spelling in case of all keywords and variable names. A lot of students come from different languages that are not case sensitive like Java is. They're not used to it, and so they use mixed case or they use the wrong case, and they get a lot of error messages. So always verify that you're using the correct case with your variable names and your keywords. At last, we finally get to run our program. Now, we're going to walk you through not only executing your program, but also what happens during the execution of a Java application, because it's very important to understand how Java and the Java Virtual Machine take your class files and put them together and run them. Because notice, we've compiled two Java files into two .class files, and we have not linked them together. We've not converted them to an executable file. You cannot run them directly. You have to run them through a Java Virtual Machine. So it's important that you understand this process. Now, you'll get more in tune with this process as you learn Java, so don't worry if some of the mechanics are a little fuzzy at first. We just want you to get an idea of how the Java Virtual Machine takes your class files and runs them on the operating system that you're running on. So let's go ahead and see how we do this. Now, the first thing is we have to go to a command prompt, and we want to be in the directory where we have our two .class files that we've now compiled. So we want to be in the same directory as our shirt.class and our shirt.test.class. Now, the first thing you're going to do is you're going to see I have a bunch of numbered steps on the left-hand side of your screen. And you're going to click each step as I talk about it. So the first thing to do is to launch the application. So go ahead and click step 1. Now you see, to launch the application, we run a program called Java. Now this is the Java virtual machine. Okay, so you're not running your program directly, you're asking the Java virtual machine to run your class files for you. So you type in Java, and then you give it as input the name of the class that contains your main method. Now you do not say shirttest.class. It knows it's a class file. And do not do like a lot of my students do, which is do Java space shirttest.java. They put the .java extension on that. No, that's the source code file, okay? That's not going to run. So you have to say Java and then shirttest. Now remember, shirttest is the class that has our main method. You must always give it the class that has the main method. You would not say Java shirt. It's Java shirttest. So what that does is that runs the Java virtual machine, okay? So now the Java virtual machine will load our shirttest.class into memory. So go ahead and click step 2. So the Java virtual machine goes out there, grabs the shirttest.class file, and pulls it into memory, all right? Now the next thing it's going to do is it's going to look for the main method in that file, and it's going to execute it. So click step 3. Alright, so the Java virtual machine now is running. It goes into that shirttest.class file, finds the main method, and begins execution of that. So basically, the Java virtual machine has now turned control over to our program. Now, the first lines of code in our main method will begin to execute. Now, one of the first lines, if you remember, is declaring a shirt variable called myShirt. Now, once a class file needs another class file, the Java virtual machine will go out and load that other class file. This is an example of dynamic loading. You see, all the class files are not loaded into memory at once. They're only loaded as they're needed. This is an important feature of Java. Okay? So now, Java's going to go out and load the shirt.class file. So let's go ahead and see that. So click step 4. So the Java virtual machine goes out and loads the shirt.class file because it needs to create a variable called myShirt, which is of type shirt. So it needs that class file. Now, if you remember, the next line of code is to create the shirt object using the new operator. So let's go ahead and click step 5 and see how that's done. So the shirttest.class uses the new operator and tells the shirt class file to create a new shirt object. So it calls the shirt class file, boom, and then we get another shirt object created, or we get our shirt object created called myShirt. Now, once that shirt object has been created, we can access the attributes of that object. We can also call methods on that object. So go ahead and click step 6. So in step 6, we're invoking the method called displayShirtInformation on the myShirt object. So it calls the myShirt object, and now it's basically turning control over to the myShirt object to run that code. So in step 7, if you click step 7, you'll see that now the displayShirtInformation method executes, and the lines of code start to run. Okay, they start to execute. And when they execute, they display the shirt information to the command prompt. Now, once this method has ended, it will return control back to the shirttest class. Okay, it basically returns control back to our main method. Now, the main method has nothing left in it, so it will return control back to the Java virtual machine. Now, when your main method exits, so does your program, and then the Java virtual machine can shut down. So go ahead and click step 8 and see how everything unwinds and the program terminates. Now, I want you to go back through and run all these steps and see if you can kind of remember what's happening during each step and why. Well, we learned quite a bit in this module. We identified the 4 components of a class, which was the class declaration, the attribute variable declarations, the methods, and the comments. We also learned about how to create a test class and what the main method was and how it's the entry point into our program. And then we also learned how to compile a program and how to debug it, finding the compiler errors and how to interpret them. And then we lastly saw how we execute a Java program and what's all involved during the execution of a Java program.